Okay, then let's get started. We have an Emacs and a bottle full of tea to keep us through the night. So let's see. Compile. Here we were. So what did I did a bit of stream. Specifically, I did the pretty printing that you can see here. Well, not only, so I'm going to show it, but previously we just had put in things as strings, so we just concatenated everything. Everything was a single line. So for something big as this, which is not displayed full, by the way, we'll fix that. But things were completely unreadable. For this, it doesn't make a lot of difference. This makes a little. So I forced the let to be displayed vertically. I did some alignment things so that we can see where things are. For the record, I really hate aligning things with white spaces. It is not the right way to do, but we're fortunate to have that right now. I'm outputting to something that is monospace, so it works. Still hate it. Alignment is kind of helpful to parse where things are. Like we can see very clearly where things are. I did something fairly simple and cheap just to get not to spend too much time. I don't know how long it took, like an hour or two on this. And like in one evening, I did a couple of things. So I did the what? Okay, I think my Magic version changed and some things are different now. Whoa, it's very different. Yeah, okay. So right. So I did this. So that's pretty printing. So I basically replaced the shows by pretties, and they're not very different, except have a few combinators, so it can abstract a couple of things, which is nice, and then like a few instructions. So like pp.group says, try to print on one line if you can. If you can't, just do whatever. So it's things like this says, align these vertically unless group forces group doesn't, you replace the lines by spaces basically. So something, and you so here we can see that like if when this comment fits on one line, it's one line, but in a comment like this that doesn't is displayed vertically with some indentation for the two inner things. This one is very spaced out, but that's vertically, but that's kind of on purpose. The other thing I did was seems to work still. Okay, I had to add a couple of these. That's kind of how I ended up looking at multiplate, like it just by following a train of thought. Yeah, so I changed let a little to do some inlining, make let, so that we don't print a ton of trivial let definitions. So it decides like if something is really trivial, it's not going to it's just not going to it's not going to keep the let because it's just a value, so you can just copy it, it's fine. And then you have this thing like if it's not used in a let definition and it's used a single time in the that's the one, sorry. So if it's not used in a definition, that's this line. And this means it's used at most one time in the common you're abstracting over. Then you also inline it, which is not quite correct in call by need. It's fine in call by name, which is what we're doing right now for simplicity. It means like if you inline under a lambda, there's really one place you inline to, but it was also not a great idea. So it's mostly for legibility. It works for our use cases enough so that we can see what's happening. I wanted to do something else at first, which was to add some like variable in the printing instead of using De Bruijn indices like this, which is but I decided that I would rather show how to do this online, so I'm going to show it in a moment. What we're going to do right now is I'm going to add this, and so that we can see the map in its entirety. So something we can see here is that we have still things referring to map, but map has actually disappeared. And that problem is mostly what we're going to be concerned with today, is that when we define something in the memoizer, it escapes its scope. Therefore, it must be lambda lifted. There's no choice about it. So we're going to do this lambda lifting, and it's going to be somewhat painful and unfunny. So we're going to do that. And we need to lambda lift according to both De Bruijn's here that just don't make sense. You know, you have a number 8 and there's 1, 2, and 3 binders. I'm sorry. They don't really make a ton of sense here. And I don't know, like it's going to match something. So maybe it makes sense because it's regraphed in, but it's not locally meaningful. So the let abstraction here doesn't make sense. And we have this map here. So these two things kind of need to be abstracted over. And that's the sort of things that we are going to try to do. Part of the answer in that particular case might be that we should, I don't know, maybe I'm saying nonsense. Anyway, first we're going to add some variables, and I'm going to show a general useful technique and a ton more boilerplate. So yeah, get ready. Where am I going to do this? Here, I guess. No, well, I need to. Okay. So we're going to use a tagless representation. Maybe I want to restore these so that we have a smaller example as we're doing this. Though of course that we're not going to see much of them for a while until we can print with variables. So that goes through a type class, and I'm going to call the type class algebra because why not? It needs 3 types. It needs computation, values, and commands. Sorry. Let's use T for thread. I don't know. I don't care. And we're going to mimic all the constructions there, but slightly differently. So I'm going to take all this as a copy and just go through this. If I can find it again. I should not use my mouse for this. Tagless. Oops. Okay. That was a mouse copy. Okay. So we're going to do CC, and we're going to immediately say something interesting. So it takes a value to everything, like everything we abstract over as a value. So we bind 1, we take 1 value as an argument, and we take a command and return a computation. If it was a lambda, it would be like something like C to C to C. So all 3 variables would be the same. The point is we're going to use the variable of our language as actual variables, and it's very powerful design. It makes things convenient in a number of ways. So that's 2 V's and a T, so bind 2, and we can continue. Case unit takes a T, returns a C, case I takes V to T and another V to T, and returns a C. Case void is a C. Return, that's unfortunate. Okay, I'm not trying my luck. I'm going to call it return C, or just ret. Let's call it ret. Let's be, you know, I don't know. Is trendy? Is that trendy? I don't know. Takes a value, returns a computation, and call takes a string, returns a computation. Easy. So that's for the first thing. So we're just mimicking everything. Int, no. There's no var, and that's kind of the thing. So call is, so we're not dealing with lets there. I guess we could, but I'm going to ignore lets. So that's actually what we're gaining out of it. We don't need variables because we're using the variables of our system. So we'll see if we change this. So this symbol takes a string and returns a value. Unit is a value. I forgot pair. Takes 2 values. Return a value. I1 is takes a value, returns a value. I2 takes a value, returns a value. Case ret takes a value to command and returns a value. Boom. And we are left with commands, and so a command is either interact, hopefully this is not in scope, might be. If you don't know about the interact function in Haskell, it's a very, very interesting piece of thing. I mean, it could be the subject of a lot of discussion. So it takes a computation of value, returns a command. And let see this time, because there's no short let, but takes a list of string and C and returns a command and T, sorry. Oh, this is a good point. Okay, it's very silly. Oops. Okay. Hello, Deepen. Nice to meet you. I'm not entirely sure why it does this. I think these are ambiguity checks. Right, so this is the first method that doesn't have all 3 names in it. And therefore it says, oh, from T and T, I can't deduce V. What am I doing? I'm doing a type of optimizer for an intermediate representation called a supercompiler, which is an interesting way of optimizing programs based on an operational semantics. And this is done in Haskell, and the goal is to work it inside a proof assistant in the future. So I thought I would be able to hold that for a while, but I need to, I should have checked what the semantics is. I think I can do, like if I do C implies VT, I should already solve that one. No, I can't do this. Parse error on where. So I need functional dependencies. That's obvious. So have C is T. The goal is then you have V implies C, V, is that sufficient? Maybe. Okay. I think I need also T implies C, and we're good. If I have one of these, I can do the other. I can find the other. So there, yeah, there's. I thought I could reveal that later. Oh, I need the functional dependencies, but I need that immediately. So now, our goal is to prove that this representation is the same thing in a certain way as the De Bruijn representation. And that's the whole fun. And that's what I wanted to show today, for the most part of the day. So I'm not sure which direction is easiest. I think the easier thing to do is to show the run direction. Yeah, if I have like a computation, say, so suppose I have an algebra CVT, and I have a computation. I might have some free variables, so I need a list of V's that is long enough to fill a few variables. Then I can produce a V, a C, sorry, it's a computation. And I need one, so run computation is this one. Equals blah, and so here we can do a run value, and here we can do a run command, and here again it's value and V, and here it's command and T. So just fill the gaps, I guess. So I don't know, let's do things in order. So suppose I've got a CC of T. So it captures one variable. Now I can interpret this, and so I've got my substitution here. I could interpret this as a TCC. T is for tagless, by the way, so I tag the tagless thing. It's silly. Yeah, like I should probably split that into many modules, but it's annoying to do that when you're streaming. So yeah, eventually, when this gets cleaned up, I will, like I did for the congruence closure. So TCC, but for TCC, I need a function. I have a function. I need to pass it a function. Is that it? Now I'm confused. Which one am I doing? Yeah, I need to pass it a function. So Yeah, okay, that's it. Yeah, so you do lambda v. So that's the function. That's the value that is going to plug. So what I can do is basically C. So I have to call run command on C with a substitution extended. So I need a substitution. What did I do with substitutions? Here it is. Subst, lift, shift. Right, but in that case, well, in that case, it doesn't really matter because the V is independent. So I think I just do V colon subst. So we're only saying, so this is not, of course, there's still values left. This is just saying, okay, so like that was the first element of this was substituting var 0. Var 0 has become var 1, so we substitute there, but we have to add this V on top. Okay, so we do case pair. So we get V1, V2, T case pair, and we have to do run command C with the V's in the right order. So I think that's the one. We'll see. It might show up wrong eventually. It's the only one where you have to care, so that's fine. And so we continue. Okay. I don't know what I did. I think I pressed just, yeah, okay. My copy and paste key are side by side. So case unit. So we do T case unit. And we don't have a lambda at all, so we just do run command C subst. We can remove that parenthesis. Fantastic. Then we have the case I. So now we have C1 and C2. On the substitution, so we do T case I. And we have two lambda V's to do. So run command C1 with V and only V, and we do that a second time with C2. Almost fantastic. No, actually completely fantastic. Great. So we continue. We have case void, which is a very unique case. Case void, because it has 0. Like it's the 0 array sum. It has 0 thing. Like the binary sum has 2 things, and we can remove this. Then we have tret. Also of a particular shape. Run computation. Ret. I hear that there's in the 0.4 version of Haskell ID engine or whatever the name is now. Yeah, I think that's it. There is case splitting that has been added, and I would very, very much love that, but haven't managed to make HIE work yet. If someone has tips on Emacs, I would. I haven't tried with Virtual Studio yet. I should probably start there, make sure that everything works, and then move to Emacs and blame my setup instead. So return takes a value U and a substitution, and we do tret of run value the U subst. I noticed that my substitution is last and where it's usually first, but whatever. And run so we do call let's say D, and that's tcall D. So we can also remove this. Fantastic. So we've done everything here. So let's do the values. So we do what? We do sim of symbol. I don't need a substitution for this one, of course. I do just tsim of symbol. That is completely natural. Run value. Run value pair takes two values, a substitution, and we do t pair. Run value u subst and run value v subst. Okay, then we have unit, run value of unit. I don't need the substitution, to unit. Run value I1 of u subst equal t I1 of run value u subst. So 2 and 2. Fantastic. And finally run value case return of a command substitution, and here we do the normal trig again, the lambda trig again. So we do t case ret lambda v, and we do c run command c with v extended soups extended by v. Sorry, and finally we are moving to run command, which has the most important being interact. So interact takes a command and a value, and so we take a substitution and we do t interact run computation e subst and run value u subst. Later. What else? We have a couple of, we didn't match var, which is a good point. So run value var I equal, we're just going to a subst equals subst bang I. No, it's got bang. Okay. Did I import data list? I did. So it's not bang, and maybe bang bang. Oh yeah, and I didn't do the let. Okay. Run command. Let decals and c subst equal. So over traverse, sorry, so I do let, here I do traverse dot underscore 2, and I do run computation. Here I'm paying my choice. Run computation e subst. It's not a very high price to pay, that's fine. And run command c subst. And we're going to, because it's a bit long, we're going to sorry, here we go. Okay, it's not happy. and that's tlet. Oh, I'm gonna remove the C now. At least I have this chance. Lock. I have this lock. Occur check. Interesting. I see. That was a typo over there. Fantastic. Look, it works. It's also completely useless still. There's a unused thing here. Okay. Boom, boom. Okay, so now we know that whatever is a value of this, we can, sorry, in algebra, we can eliminate things on it. And we're going to do it soon. But for now, first I'm going to do the reverse direction. And if we were lucky, the reverse direction would be to prove that computation value command is an algebra. But it doesn't quite work. Almost though. So what we're going to do is we're going to prove that. What exactly? Do we have a... Okay, no, it's fine. So we're going to prove that the types value arrow computation here it's command and here it's value, that this is an algebra. Oops. So this returns a term of one sort under the assumption that we know a substitution. That's what we are doing. So we have to prove all these things that we're doing, which is going to be very mechanical again. So TCC is the only difficult case, because when we've done that one, the rest will flow. So it takes a function as an argument. So that would be my command, basically, except that it has a value argument. And so it also can take my substitution, for instance. So under a substitution, now I need to build a computation. So I can do CC, that's what I want. But now I have a new value. So I want to say that, sorry, like, yeah, I'm getting ahead of myself. So I have, so C, this is a function to C. So C is a function still. It's a function that takes a variable from a list, like a variable under list, value, sorry. So the value I'm going to take, so here I want to put C basically, right? But this is not the right type. It takes it takes a value that's a variable basically, and a list of values. So I need two arguments to it. And the first one is the variable, and the variable I want is the first. It's var0, yeah. So it's really I was going to say it's the head of the list, but is it true? No, actually, I thought I knew what it was going to be. Let's take a rain check on this. So we want the second argument. The second argument is a substitution, and the substitution I want to just augment the substitution. There's now one new variable, and all the other variables need to refer to something else. So I want to put shift of subst. That's the function that pushes a new variable. Now, this is supposed to represent var0. And I thought I knew what that would be, but I don't. Give me a few seconds. Let me breathe. A couple of things that it needs to change value after we go under. See, I prepared things in my head instead of looking at the literature, and now I'm not. Bad habit. I thought I knew what I was doing. Famous last words. Maybe I'm wrong. Maybe it's not under a substitution, it's with a substitution. Is that correct? No, it's not either. Okay, let's just think. Sorry, I'm going to be quiet for a second. Right, it's a bit more complicated than this. So we need to basically need to come up with names. I don't see another way to do this. So we need to group everything. So it's not, so a list of value will not work unless we're adding to the end, I guess. Or well, yeah, we could add from the end. So what's happening? What we need to do is not like we can't address in a list like this, at least not from the beginning. If I change the way I address, because I need basically variables to be interpreted by something like this, and I need a unique way of doing so. I mean, I don't like. I need to lift the thing every time I do this. So yeah, this is not necessarily bad, but we need to count from the end. So maybe what we can do is we can do lambda subs prime, and we do So reverse subst prime. So now we can index from the back. Oops. Reverse subst prime. And we take the value currently length of sub. So that's the new value. So it's 0 initially because we just added 0 here and lifted everything. And that ought to work. Okay. So we'll need something for this. Because we're not going to repeat this every time. So let's give ourselves a tvar of type value to value. So that's my my final type. But what I want is because I take an I, so an int. It's not always going to be the lengths, so we'll have to be a bit careful. So tvar of I is lambda subst to reverse subst bang I, and so this is tvar of length subst. So case pair is always the most complicated. Takes a C and a subst. So here we're just using integers as names, so we're generating new names. So the point is that now my new name is length of subst, and I just put 0 at the front, so I read the list backwards. So I index from the back. So my index from the back is length subst as well, because I'm the last element in something of size length subst plus 1, and in that case it's 0, and everything else is shifted. So that makes sense. I have to be careful that this list needs to be finite, and unlike normal substitutions. And so that's all there is. So my initial idea of doing smart things easily is just a bit more complicated, but it's not too bad. So case pair, so carefulness is necessary. So here we have C, have 2 arguments, and we have shift of subst, because we have added 2 things. And so the first variable okay, so I think it's tvar of length subst and tvar of length subst plus 1. Oops. Okay. Oops. Yeah. Here the problem is that this should not be parenthesized, but this should. Okay. So now it's fairly straightforward. So both these cases might be reversed and we might see some troubles. We'll see. Both of the case pair things. It's so easy to get things wrong. It's just remarkably easy on stream. So case unit of C subst, I guess. Yeah. and then t case I takes C1, C2, and a substitution. In this case I, here it's C, we do a tvar of length, of length subst, and the C1, sorry, C1 and shift subst, and the same with C2. Easy. TK's void is of course the easiest. It takes substitution, but we don't really care, and we interpret this as case void. tret takes a value, substitution, and we return ret of v subs, I think. There's no binding, is the point. Let's return. And then call, tcall, with a string, so that's all of d. tsim is very similar. Sim s. So we have t pair takes a new v subst and returns pair of u subst v subst, and then t unit of u and sub. This one is easy. Actually, I need this. No, it doesn't. Okay, I don't have a u exactly. That's unit, and then ti1 of takes a u and subst and returns I1 of u subst, and ti2 of u and subst returns I2 of u subst, and tk's ret of c and subst. This one needs a binding, so it returns k's ret of c, takes a tvar of length subst and returns shift subst. Here we go. No, oh yeah. No more errors. And then finally, we have tinteract, takes a command and a value, and a substitution, returns interact of e subst and u subst, and t let of decals and of c and subst returns. Oh, that's interesting. That's oops. So over traverse dot underscore 2 apply subst. Let's be a bit ridiculous, and here we do c subst. Fantastic. So equipped with that, we can do interpret computation. So if I have a for all CVT algebra CVT to C, then I can get a computation out. Right, and interpret computation. I think there's a bit of a lie in this. I would need to have an actual substitution as well. But for now, we'll just assume we do only closed terms with this, and x66 needs an actual substitution to lift unbound variables. It's okay on closed terms here. Now, when I forget, I will have like you know, I will resent myself for forgetting because it's written. I'm going to forget. Of course, I'm going to forget. We're going to come back to here in months. So anyway, so we do that by taking my like computation thing, and we just do e at computation. No, okay. That legal polymorphic. I need rank n type. Yes. So this has one extra argument I need, and it's a list of value, and I'm passing unit because there's no variable to substitute yet. Okay, and we can do this again 3 times. So here we do value, and here we do command. So here I need to put value, here I need to put the command. And yeah, I'm going to change the letters here, but apart from that, the code doesn't actually change. It's oh yeah, there's another thing, of course. That's here and here. Here we go. Of course, the type of the argument can't be the same. I can leave that as an exercise why this stays this annotation. It talks about computation everywhere. There's a good reason. Well, a good reason. There's a bad reason, let's say, but it's a strong reason. So, okay, now we can read closed terms written entirely in that style with lambdas as thingies, and on the other hand, I can also run whatever. So we're going to go back to our printing term, and we're going to define an algebra on printers, basically. So can't quite be on printers. Again, I will need a list of names. So here I'm going to weep because there's no organization at all in this file, but so we're going to do instance algebra of, so we need a we need a list of guess we need a list of strings. These are just names for variables that I want to print, and pp doc of any annotation. We don't really care where. Yes, that is a good point. It's 3 times the same argument. Okay. If you don't use mutually recursive types and instead you use or in addition you use some sort of index type that gives you each possible style, then this would take a single type, I guess. But that is parameterized and yada yada. T. So let's go, I guess. So I'm going to take the code there. I'm going to do it one type by one type. And what was the motivation for the titleless final? There were two motivations. One is good and one is bad. The good motivation is what I'm doing right now, like having a way to introduce variables in inside the it's not more expensive than writing a variant of the thing with name variables, and I just want to add names to the pretty printer. And what and I'll also, to write terms, it's going to be way easier to see what we do that way instead of using De Bruyne's. So we can probably debug a bit easier. The other reason, the bad reason, is I just thought that it's just interesting to demonstrate how to do these sort of things and how like tagless final works. By the way, I hate tagless final as a name, but another day. How this style encodes naturally binders, and I find that's pretty cool. Okay, well, it's not so that would be so TCC. So it takes a C and a supply, and that's the thing. So here we take head of supply, we measure the supply is infinite, and here we take we do C actually of tail of supply. Then we do no, sorry. Ooh. Okay. Breathe. Okay, here we go. C, we need a supply as well. Why? Because I'm an idiot. Next question. And this is also not correct. It's not the first. Okay. I'm not utterly surprised. There's something missing. There, I need a variable. So let's do it slightly differently. Let x equals head supply const pretty x. We could give that a name. But whatever. So we introduce the name here. Parser, yeah. So we introduce the name. We take the name, the first available name that we have, and in what? And then we just, so we take it away from the supply. It's not usable anymore because I use it here, so I don't want to shadow it inside. And then what we do is we say, oh, when you find the variable, you just write the name of the variable. That's all. Here, we're going to do a similar thing. So here, we're going to do so I'm going to change the style a tiny bit. Sorry, bang bang. Okay. Try to write idiomatic Haskell. That's why. And we take the first one. It is a terrible style, by the way. Never write this sort of code in prod, but like, you know, when it's time to do something short, kind of works fine. We have the X and the Y. I don't remember in which order I need to pass them, of course. So we're going to have to try it out. It's a const of pretty. I think it's this one. And drop to supply. Boom. Okay, so here you can remove that, add a T, add a supply. Here we don't really need anything, so we go C and supply, and that's all. Fantastic. Okay, now again, remove this, we add a T, C1, C2, this stays. So we're gonna name both of them the same, whatever. There are some way better ways to do this. New plus x plus x. And that is, we do C1 of const pretty x and tail supply. Okay. Add a T. So there's a supply here that we can ignore. Fantastic. Here we have a supply. And that would be V of supply. I called it TRET. Okay. I don't exactly know what I did, but it worked out well. T equal S, supply, S pretty. Oats, okay. That is quite correct. Right. Okay. That actually works out fine. So pp.pt $this. Again. Yes, here. Okay. So now we do values, which is going to be a bit faster because of how okay. So I have a supply here that I can. I don't have tvar actually. That's the point. I got. Here I can ignore the supply. Funny. Pair UV, so and supply. And here I can remove this and pass the supply, and here I can remove this and pass the supply. Unit needs a supply that I can ignore. That's U of supply. That's U of supply, and I forgot to add the supply over there. Okay, is ret. I called it, and here I need to focus a little again. So here, X, space a bit. Here, that is tail supply. Oh yeah, sorry, exactly. Constext. So then we do the command ones, which are a bit more verbose, for such is life. Whoa. So this takes a supply. Can remove this. Oops. Takes a supply. Okay, now we could quite possibly demonstrate my pretty printer already. So I need a supply. So let's say that var name supply, it's a list of string, and you know, let's do something like this, like so x z plus plus a W. Well, I guess 26 is infinite enough, right? Oh yeah, sorry. No, okay. Need to know where things are on my keyboard. Yeah, so 26 is about infinite. That's the point. So that's our infinite supply. And when it errors out, we'll add more things. So now, instead of pretty computation, what do? We need to do run. So oh yeah. So it's a list of doc_n, and unbound vars is map unbound to this pp.doc, yes. Sorry. I'll manage. Let's just do let's see, show of run computation of unbound vars and what var name supply fascinating. I guess we could do it's not happy. Why not? Really want something to be of type pp.an and the value specifically y. Okay, that is a bit troubling. Just out of curiosity, if I do v I do run value here, and I usually call them u. It's a very different error for some reason. Run value takes a thingy, a value, a list of v's. Oh, I see. So that's supposed, okay, so that's the problem. The problem is that it's supposed to be a list of supply to this, and it just ignores the supply. Okay, that is much better. And now we don't see anything yet. We need to do the last one, because that's the only one that counts, really. And there are already inbound things. This colon X is surprising. Did I write it? Yeah, I did. Okay. Oh yeah, that was what I was casing against. Well, that's not bad. Of course, it's just wrong already here, but we can work that out. Like there's 3 inbound variables. Oh, but that's okay. That's probably the same bug. So, okay. So that's kind of the point. That guided me fairly straightforwardly by the type to an implementation of my printer. It would have definitely been more straightforward if I had put the names in the thing, but then I would have had a similar difficulty to generate the name while I was doing the translation. So here we're working directly, so that's basically a fold over my type, and that's pretty clever. Because we're doing this like run computation thing. It's just a fold over my type. Pretty much, we just call the corresponding thing every time. So we just fold them together. So it's a one-pass thing. It's pretty cool. Of course, it's very slowly implemented, so the one-pass thing. But where we're going to gain a bit is that we are going to be able to change that a little. So we can do algebra CVT takes a V to C. V to, no, sorry, here we are taking a, we're taking a C to C, I think. Do we manage to do this? Let's see. I want to do t-case pair of lambda x k and I want to do t interact of we want E here applied to something, and here we want to put K. I'm going to see soon if things change. And then we'll have to change a bunch of things. So what is here? We want to pass X, but X is a value. And we're expecting a computation. Therefore, we need to do this, basically. We don't do the variable, but we need to do the variable here. So we're going to still keep the var thing, but we're going to do var. It takes an algebra CVT and a V returns a C. And var of X equals TCC of lambda K, followed by T interact of T return X and T return K and X. Okay, that correct? Probably is. Gonna keep that around for a second. Var X. It's T-ret. I changed the name initially and I don't really need it. So now it's good, but the things at the bottom don't type because they don't have the right expressions, but we will make them legible. So here again, so we do algebra CVT, return C to C to C, and app EU is CC again. It's written on the top anyway. Lambda K, and we do T interact. So we have E here, and here we do a pair of T case return something, and that would be K. Yeah. Oops. And here we do lambda K prime to T interact U K prime. TK is ret. Oh, that's TCC. Now I messed up something, and that's very painful. There's a pair somewhere. Yeah. This is the sort of thing where it helps a lot, because who can read this? And then we'll have to debug the five places where I had to choose the order for case. That's going to be awful. For pairs, but anyway, CVT C to C to C to C. So that's TCC, and I take lambda K, and I do T interact, and U is the right thing, and then TK is ret, and I do lambda R, and then it's T interact, and right, and here it's TK psi. Here we have lambda X. Right, I forgot something here. CC. So that is K. And here we have E1, and we do var X. And here we have lambda X again. Let's say T interact. This is K, and this is E2 of var X. And here at the end, it is supposed to be R. Yes, no, what's wrong? Oh, yes. Indeed. Very good. So here we do algebra CVT string.c, and it's just t return and tsim. Unit is algebra CVT to C, and that would be t unit and t ret. CVT C to C to C. So, oh my god, I didn't write the code this time, so now I have to feel my way through. Let's do UL as the value of EL. ER, so now we do case return of lambda UR, and then, oh, I don't like this. Can you, this indents weird ways. Okay. T interact, T ret, T pair, that would be UL, that would be UR, and that would be K. Whoa, yes. Yay, and that's case pair, okay. C to C. So C, C, C to C. Oops. Okay. So again, so we need the continuation for the entire computation. We take U, which should not be called U anyway. So TK threat, so we force it, so we get, we'll call it U prime for good measure. Interact, and here we have case pair, which takes two variables. X and Y. Returns interact that would be E of X and Y, and this would be K, I think. Right, that's after the case. That's what we do when we're done. And this is U prime, because that is the scrutiny of the case. It's not happy. Ooh. Ooh, 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 yes. The type error is pretty scary. And this, again, is an algebra like this. To C, and this is TCOL. Okay. So actually I'm going to push as well, just to be sure. We haven't, like, okay, it's almost taken 2 hours. I thought it would be shorter. I'm a bit, we'll finish this quickly and take a little break. And like a minute or two, maybe a little more. So so we're going to do optimize prime, very funny. For all CVT algebra, CVT to C to command, and optimize prime of C is done with interpret command C. Optimize of. Okay. So I want to do optimize prime. That would be a T. That would be a T. And that would be lam $x into lam dollar, oops, I ignore the thing and I do X, oops. There are still errors. I think it let's try something. No. What is this called thing here? Oh. Okay. I don't remember why I did this. I need a short break. I'll be back in a few minutes. Stay tuned. Okay, I'm back. hopefully. So it resumes a computation. Promise name. Oh, right. That was just a, but like, I think just call is good, right? Right. Okay. That's fine. That was an easy fix. Could not deduce algebra T V0 T. Right. Okay. That was just silly. Okay, that was easy. Okay. So this did what we expected. It's a good start. The lam, you know, it takes X, returns X. Okay. Now we're going to do the second one. Okay, so that's not going to work, of course. So we add a T. I don't know what I did. I did again. Oh, I see. I know what I did. Case I of simx and lambda underscore. Hey David, how are you doing? Did you finish your thing? T-unit. Damn it. Oh yeah, optimize prime. Oh, yes. Yeah, I noticed as well. It's funny, isn't it? It sounds like a transformer. When it's midnight, everything is funny. So what the hell is this? Okay, so that's a lambda that we don't actually use. Right. We can even remove this. Fantastic. Okay, and then we have this one, which is const again. So it's that one. I can right, it's really the name the same as earlier, but under a lambda. So here we have we have very little. So that is case on X, and we return A in one case and B in the other. It's a boring thing here. It's lambda, and we do const. So we should see. So of course it names the stack Y, because there's no distinct supply or distinct way of supplying names for the stack. And in that case, the stack is stuck because it's just the empty thing. Could give it a name too. And so it says, okay, I'm under lambda. I don't really do anything, and I still evaluate another lambda here. That was the test. Optimize prime. I can type, I promise. Okay. Let's put this big, because I can't read anything here. So this is a lambda, and we ignore this. So that's sort of the same story as earlier. We have no need for a name here, and we can remove this. And this one is const again. So we can I can use my mouse. It's going to be slightly easier. Sure. So that's one of them, and this is const as well. Here, oops. Right. I'll succeed. Let's see if I can. Oh, it was far back. Okay. That looks correct in this time. Oh no, there's more. What did I write? Oops. The real question is, why the hell did I write this? Oh, there's a, oh yeah, that is true. I shouldn't call that X then. Let's call it Y. And there's already problems in this. Which there is just because of my failure to abstract over all the variables, which it's going to be boring. I'm not sure we're going to finish today, but what I promise is whatever I don't finish today, I'll do offline, and we stop there because it's been long enough. I just thought that doing the tagless encoding was kind of more fun than actually doing the debugging thing. So we're going to start doing the other one, but I'd rather I decided not to do the whole tagless thing out of here to avoid like to skip it. Basically, it is just that there was a. That's the identity. X. And there's a. I systematically ignore that value every time. I just use things as an if. Right, so here I evaluate in this second branch. So there's an A that here it was an lambda abstraction, a const B basically applied to A, and that disappeared. Very much sure. Whatever. And we can finish this later. So probably we're not going to see everything, but I will improve a little so that we can see. So this has been done. 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 Okay. Before I actually commit, I just want to remove this and this. Well, to be honest, there's a couple of them that I did off stream, so they were solved before I started, and I've been at this for 2 hours. So, there. Yeah, I just didn't remember I had these to-dos. I didn't notice, so I didn't clean them up while I was working. So these ones I did off stream. So most of them I did earlier this week. Took me about like 2 hours total. Nothing very scary either. Okay. So okay, so what do we get to do? In order to abstract over all these things, I will need to make an n-ary mu, basically, that instead of here I take 0 things, here I take 0 things, and I know how to take 0, 1, and 2, and I want to take n, so I have 2 choices. I have 2 choices, did I say? Choice 1 is I just iterate mu of pairs. It's possible, but it has one cost. Sorry. Ooh. Everything's fine. It has one cost, which is that it's going to be unreadable. Look at this. It has the first one and the second one. Quite so, quite so. So if we look at this, we have 1, 2, and 3 variable. That's sort of fine, but like the map example that is not here had, you'd find terms was much more. And so they would appear as mu of a pair followed by a mu of a pair followed by a mu of a pair. Well, actually, one thing we can do is to do this, not change the grammar yet, and do some collapsing. That's kind of fun. But I think at the end of the day, whatever we're doing here, we are going to want n-ary products at some point. So I think I might as well bite the bullet now. And add binary products, n-ary products, so that we can do the abstraction. It's going to flow better. Where I do pair and unit, I can simplify this a little and do tuple, take a list of values, and here that's kind of tough. Yeah. So we need to know how many. Yeah. Should be a nat, but let's not worry too much. We don't really need this anymore. I can remove this code. It's been replaced, made redundant. I still will have plenty of interesting things happening. Right. Tuple of use and that would be traverse and value level use and tuple. Of course, unit is tuple of the endless, yeah. of course. What is the function to compose a value, a function n time with itself? So iterate n, so that should be a case tuple n, iterate n shift on subst, and I take the nth element. This is not horrible at all. I'm fine with this. I'm completely fine with this. So get to change this. This is a case tuple. Takes a list of values. And there's not that anymore. And here we have t-tuple. Take a list of values and return a v. So here, what I do, case tuple n, subst, so t, I need the n here as well, right? I think, because I can't know otherwise which size it is, so I need an int here. And I don't want this one anymore. Case tuple n, so t case tuple n, so it takes a bunch of v's, run command, and that would be v's plus plus subst, I suppose. The order of this is awful. I have, like, at this point I have no idea what the order will be. It can only end in disaster. I put them in the same order, so I think it's the reverse to what I've done so far. It's kind of fine, I suppose. Tuple use so that would be t tuple dollar map lambda u to this on use. We're getting there. Case I is wrong for some reason. What did I remove? T case I? Oops. Let's unremove it. Hello. Oh, I know what my problem is. Okay, and little v. No, little k then. Yes. It's back. For some reason it's on top of case tuple. I think I want it in the bottom here, or below it anyway. So here we have case tuple. We have an integer n. Ah, oh, sure. So I think it's just n minus 1, yeah? in this game. Okay, at this point, I have zero trust in what I'm doing. Most likely, I'm turning things around a little. We'll see soon. Got something wrong. Yeah, I'm pretty sure the two orders are not in agreement. I don't know how I did this. There's magic command somewhere. It would be case tuple of 0. So case tuple n of tuple use, and that is sort of where things go. They sort of matter here. Use, yeah, that's sort of the only possible order. But like such that n equal length use, otherwise it's not legal. Okay. There's still quite a few. How many did I have? Okay, so that's sort of the same story. That is case tuple nc tuple use such that n equal length use just command subst. So I think right. So I'm passing them in the same order now. So var0 is the one to the left in that list. So I will have to go back the second occurrence of case tuple, and I think it's the one that is buggy. No more flag check errors. Ah, yes. Ooh. Fun stuff. Oh, that's the printing. That's okay. I have an n. So x's map pretty to take n supply, and here we can just mu x's c c map const x's, I suppose, and drop n. Boom. We're almost there. T-tuple use map supply u damn it. There are still quite a few errors. I don't know why. Right. Okay, this one is done. This one is done. Okay, I was a bit scared for a minute. I'm not scared anymore. Yeah, that makes sense. I need this one as well. So it's a case tuple, and that was already, it was already correct, I think, except not. Needs an N. Okay, right. There's no N here. Okay. And that is tuple as well. These are just silly mistakes. Yeah, okay, that's T case. Tuple 2. That's going to be annoying. Oh, sorry. It's going to annoy me because I will have to deactivate the warning, I suppose. T tuple I should define T-unit. Otherwise I'm never going to see the end of it. Where does that happen? Right, okay. Because I use it a lot, so I can define, should be the smart constructors, I suppose. Well, I'll define it here, whatever. I'm too lazy. V and T-unit is equal to T-tuple of empty list. Okay. What does it matter? I have one argument. Oh, yeah. That's case tuple of 0. Okay, that's a bit annoying, but whatever. Tuple blah. Tuple blah. You know, like, that's the second time I'm fixing this. And now I'm guessing, yeah, the optimization is completely out of whack because one place in the order, it's just wrong. So it's case tuple, I think. This one is good. This one is good. This one is good. This one is good. Maybe tuple that does it wrong. This one is wrong. And that looks better again. Fantastic. Boom. We have tuples. We don't see the difference yet, but they're printed because it was sort of prepared for that. The whole printing thing. Okay. Okay. by the way, I said last time that we'd study the way the splitter does, like it passes variables around and definitions around, and mostly it doesn't. Like it does it in very small steps, and the splitter in the paper is not very detailed, unfortunately. So I'm not focusing on this today, and I'll improve the splitter whenever I want it. We might have to. Anywho, we want to fix this, and to fix this, we will need to have. Ooh, this one is bad. I don't know why this one happens. Actually, was it there before? It was though. That has case pair, right? Yeah. So it was already there. Interesting. I didn't notice. Oh. I'm not sure anymore. It was not in the right place. Damn it. It's in bound 1. It's not the same. Oh my god. That's not good. X, Y, Z, D3 and bound 1. Damn it. Here that was what I needed. Okay, now it's 0. Ouch. But that's otherwise the same expression. Bugs exist, I guess. But everything looks correct here. That's A. That's so much more readable. 2x b 2x I yeah. That's the and the lambda thing. So it does, yeah, it does A and then continues. And this one does nonsense. What do I want? Okay, so we need to collect all the variables and give them binders at top level. I guess we can do that with a traversal because we know the level, and so. But how do we generate new variables? So I'm thinking a little. Okay, so so where's my memorization thing? I very, very much need to put some order to this. Sorry, not here. So I want to do abstract vars. So it's going to take abstract vars, computation. We need to do that recursively on commands, etc. So it takes the computation. It takes it returns in the state monad. Do I have state imported? I'm sure I do. Yeah. State. So the state is an integer. That is the number of variables that I have created, this integer. And I return a computation and a list of values values, which are basically vars, but I need to pass them. Okay. So in the first, and we're going to do abstract vars computation equals blah. We're going to do the same thing again. So this is what this is value, and this is command, and this is a command, this is a value, and this is a value, and this is a command. Yeah. And this one is basically what was the how was it called? Computation subs. Right, that's the one. So I'm going to ignore everything basically here. Computation subs applied to abstract vars computation, abstract vars value, abstract vars command. Whoa. Oh, it is an int. I'll need this actually. Oh, okay. Sorry, that's... I don't have writer, of course. So... Yes, so they have the same type thing. And so that's value, that's command, that's command, that's value. Boom. So same for commands, I ignore everything. That should be command subs. And so abstract var value has two cases. So level var, I know, var I, and then here we do a couple of things. In here, we need we will abstract over var I. So we are going to get the number of things. So I should write somewhere the state int is the number of already generated binders. So n, there's n generated binders. So that's get, sorry. What we want to return at the end is var I plus n. Note at level 0, var 0 is a free variable. So that's quite the right formula, but yeah, okay. We'll see later. State.get. But we also need to increment, so we need to generate the new binder. So we need to, what's the thing for writer? Put var I. So that's something that abstracted away. And I need to So modify +1. So I think that's it. If we find a variable here, we say, oh, we get the state, we tell the name of the variable, we increment. So we emit, we say, okay, let's add a new variable to the list of things that have been removed. Say, oh, there's one extra variable to bind, and then this variable. So we're at level I. I don't know why I said I. That should be level. We're at variable level. So we need to walk level things to get to the outside of the first new variable, and we need to add n others to get to an extra variable that has never been assigned before. So now we do level and we do u, and we do the same as the other guys, except we do level and u here, and here it's going to be value. It's not completely correct because we are not abstracting over vars yet, but this is already quite a bit of but this is going to put us in a somewhat annoying situation where, sorry, we're not going to compile for a while. Probably, I'm not sure. Probably. So there's all these things where I do unit things. And the these one case double of 0. So when do I call bind? Here. So exists is a magic function. We'll have to check that. Okay. So let's think. Right, so here promise needs to return something different. Need to return me an X, which is my name, I suppose. That's my new name. But also a list of the free variables. Here I optimize the state. Do I need to abstract over the free variables again? That might not be the same number. I return a string, a list of values over which we've been abstracted, and a new state. Of course, this is absolutely not what I'm doing. I don't remember what promise 0 does. Where is promise 0? Oh, here it is. I might want to change the meaning of promise. It's a state. It's got right. It's got free variable like right, like free vars is an integer. getting interesting. So we generate a phrase name. Prom is 0. Revars. Right. So immediately here, I need to run state. I'll put something that makes sense. Run state 0. You start at 0. Of state of run state of run writer no, sorry, run state is the outer one. Sorry. Here I put, I don't have an abstract var state. That is a good point. I believe that can help in a weird way. State takes a state, returns do I need this and this? This is the size of this. I think. Yes, it is. Let me simplify a bit, all this a little. It's going to be slightly less silly. Let's state modify gets length. We can remove this, state modify. Right, it's a bit simpler then. Just get the length, add a new variable at the end. So now we can do run state, and the state that originally is the empty list, and the function is, okay, no, I might not even do this. Let's wait a bit. Like abstract thing takes a state and returns a pair of I never remember which one is which. And abstract var state equal run state empty list of go and so what is a state? Thank you. go of state decals and Command C. So sort of all the same thing all over again. Over. So sorry. So we do state. We do over traverse dot to, and we do abstract. Sorry. Abstract vars computation of 0. And that should work. And here we do abstract vars common 0. State dollar state. Okay. It's not over, it's traverse of. That was the problem. Now that is better. Here I can say that st prime and free vars. I'm going to call it vars. Is abstract var state of. There's still a bug, Everly. Of st. Now prom is 0. You can say length of vars, and we can return x the vars st prime. It's not going to quite work because something wrong. Right. Let. It's not in the monad. Fantastic. Yeah, I could have written it in a different way. Here, of course, here we get promise. I don't like this. I'm abstracting all the variables. Like I don't abstract let bound variables yet. But I don't like this. So as long as it's not let bound variables, it's fine. But the let bound variables, I don't really want to abstract. at least if I have them somewhere available. So I'll have to make a check that they are really free, I guess. I think that's it. So if it has meaning within the context, no, still. Something wrong. There's something I don't get here, and I didn't anticipate it well enough. But anyway, so we get st prime here, and the vars. So here it's tuple vars, and here we optimize st prime. Wrong order, is it? Wrong order. Shit. Sometimes Emacs too smart. Ooh, that is worse. This is much, much worse. It's funny, but much, much worse. Here is the thing. So bind. So that's a bit of a mistake. That's not quite correct. I'm not sure I need the free variable length here, but may need it in bindings. So instead of a computation, I want to have a command. I need the integer with number of, so int command. So bind string int command. And that would be okay. Okay, and so we fix B's by okay, I don't care. I'm going to change this. I'm not going to do this quite yet. I think we might want to have the int separated, maybe, perhaps, but at the time, for the time being, so case tuple like this. Oh. Since it's always a case tuple, we might want to expose this. It's still very, very bad. I did something wrong. Mu x, y, z. There's not even an x in data monoid is redundant. I think data writer is control writer is redundant, really. Okay. So what have I done? Oh, I captured the bound variables as well. Here, where I is larger than level, like this is going to fix a ton of things. Oops. Ooh, that was it. Not quite great though. There's still bound variables here for some reason, and I don't know why. And here, so I'm bad. Okay. Let's start with that term and see if it's unoptimized. It makes sense. Fantastic. Okay, that's funny. Ouch. That doesn't look good. Okay. Why does it work sometimes and not others? Give me a short second. Okay, I get it. It's just stupid. It's what is the name? I think it was var supply. No. Var name supply. Here we go. Woohoo, big term. And it's too big. Okay. That doesn't help. I don't see it. I don't see the entirety of it. So how about I did some trivial simplification on it, but there's only trivial simplification, so I'm not going to see much happening there. Well, let's have a look. Was it simplify? Right. So if I do simplify of interpret command bar. And there's already a problem, and bound 0. That's this y. And became unbound 0. What if I change simplify to only do ceasing? Oops. So there's already an inbound 0. It's supposed to be x. Is x to be found anywhere? X, sorry. There's something wrong. I think we just messed stuff up somehow. I don't know if it's a printing thing or we can't even see the entire term. That's become a problem. Fast compile, so I can look at bar prime. I can't for a reason. This one is correct. The X is here. But as soon as I start reducing, so there's if I do simplify, and here I do reload, and I do R prime again, and there's something in bound. So either in simplify or, well, actually that's a good question. What if I don't use simplify in MATLAB? It might be a bug in simplify itself. MATLAB. I think I need to stop soon. Okay, so the bug happens without simplify. I'm a bit disappointed because I'm obviously tired and I'm not going to be able to do much more today. Well, I don't know. Like, there's not a lot of fun stuff happening ahead of us. We need to do some pattern matching, which we don't currently do properly, so that when we check for existence, we can reuse things that have particular shape. So we do, it's fine, whatever. And yeah. So anyway, I don't know what's happening here. Maybe there are two bugs. Like, does the bug happen without? So, What does it happen if I remove the memoization, for instance? Happens. It happens if I remove the memoization and simplify. It does. So it also looks suspiciously similar. So wherever the bug is, it's pretty deeply entrenched. Gonna be a printing bug. Bound 0 and bound 0. Well, it looks like it should be X as well. Yeah. I don't know how to approach this right now. var2 var1. Yeah. But the bug happens without memoization. It's not a printing bug. Now we know it's a real bug. So that's not it. This is most definitely correct. That's correct. So we do the normal substitution, except that we add var 0, var blah blah, var n, and we shift, we lift everything by n. Sorry, var n minus 1. but that's exactly what happens. So we shift n times. So that's 0 to minus n minus 1. Isn't that already handled by subs, by the way? Well, that's because we didn't take the int. Oh yeah, no, because shift is not something that happens, yeah. Yeah, whatever. That's correct anyway. Okay, here we say that var 0 to var n minus 1 in that order from left to right reading. We got the variable onto subst. And so let's anyway, that's not what failed in that case. I thought I'd already seen that. Oh, I see. Right. That's correct. I think. Anyway, the thing appears after reduction. So that's not where it's going to happen. That, on the other hand, could be. Though that is correct. Pretty sure it's correct. Right order and etc. But the order is not even the problem. It's something that escapes. So at some point, there's something that isn't shifted by the right amount. Why did I get 2 1s of 0 1? That is very curious. It does look very unlikely to be incorrect. I'm gonna add one. I'm gonna add just a variable start with, and I'm going to say, I don't know, 5. Okay, so there's nothing wrong with this. I add 5 to it, and that looks correct. Okay, look, I have no idea what could be going awry here. Sorry. And as I have no idea, I have to take some time on my own. It's a bit of a disappointing end. So let's just go over what's missing. Right now, when we have the promises, we compare the meaning exactly, which should never really match. And we kind of want to say, oh, I'm going to use the meaning as some kind of a pattern match thing. No, shouldn't be too hard. And and yes, light blue, blue, fluid bleed, boo. I think we might even be able to do this pattern matching using the generic union library, because how first order terms are with De Bruyne's. So there's that. And well, that's pretty much it, honestly. And so debugging all this, which evidently we haven't managed to, because there's something that escaped my understanding for now. It really looks like a reduction bug, but I don't know what causes it. And so I'll have to be very methodical and try to remove a lot of things and just let the simplification remove rules one by one. Hopefully we can do this, I think. No, sorry. Okay, so we can observe that it happens during the optimization process. I can remove this. I don't really need it. Okay. That's sort of all we have, yeah? Okay. So I can remove memorize and it still occurs. Yes. I can, what's my modification? I want to definitely to stash this. Okay, so memorize removed, simplify. So in Mucklet, remove the simplify call here. So the problem is not in simplify anymore. There might be one. So now we're going to see in step command. So if I remove this, already have it. If I remove this, it's going to be big. I'm not sure. We'll have to check in GCI, I guess. So here we have just case return. Oh, yes. I have to copy it now. Here, we don't have a problem. Just case return. And without case return and just case mu, CC. We already have it. And there's nothing, we don't. So case mu just does one substitution. We go up to D in variable names. Mu k, for real? Where's my I and my J? Here they are. Oh my god, we're going far, far down. Well, that's just a printing thing. That can't affect the bug. Well, we're only halfway there. It goes down to W from X. So we do CC and we see a subst with one thing, and that is sufficient to trigger the bug. Is case tuple alone sufficient to trigger the bug on this example? I'm sure if CC does, then everything is capable under some conditions, but no, it doesn't do much because I kind of need mu anyway to do anything. I think it's kind of the point. Quite remarkable there. Mu is so innocent. It can't really do much. The let case doesn't serve anything. You don't have the call case either, so could even remove it. I don't know how to look right now. Like the substitution looks perfectly reasonable. We shift one in each branch for case I. We shift ones for case return. And these are the only binders, aren't they? Plus, that's not what's happening here. We have something that is become too big for some reason. Too big. Too big. Case double looks really, really correct, and that is the one that is most likely to give me a bug such as too big. It's a bit annoying that we don't have a smaller term to generate this. We can probably use something smaller. Simba. Right, so we already see that thing, but it's going to be much smaller when I remove Okay, so now we can see something. So we have a single mu. Really? That's not many. So we have a single mu. Apply to y. No, we have two mu's. Sorry. So it's apply to y. And the y should go there. And it does. I have another mu, which is this one. This one, mu a. It's applied to this thunk. So the thunk that's a bit weird. And the problem is that my thing is ill-typed. But it isn't there. So we go another mu xy, because we can't really do anything. we'll simplify the thing. So we get this thing here, but z is replaced by y. Okay. And then we have something like this where I return yada yada. So I substitute this, and this x here got substituted somehow, but shouldn't have. Either by the first mu or the second mu. I think there's something we can do. But I'm going to exit here. Load GCID because I'm not going to see anything otherwise. That's the one. We can remove these two for the time being. Okay. So now, okay. Oh. Okay, that's the original. Hasn't done anything. Because I have the CC deactivated, I guess. Right. Forgot to check this. Okay. 1 is not enough. 10 is too much. So 5 is too much. Okay, so 2. Ooh. That is not what I expected. But 1, I still have my original expression. And 2, I've got everything reduced. So it's not, there's a, yeah, okay. It's just, they both are reduced independently, I guess. Is that what we expect to start with? I'm not sure. It's so we have, it's written here anyway. Lambda y, case y, sim b, sim b. So we expect it to be xy and x is a thing, so it must be compared to a return which acts as a force. Then it shouldn't be a mu x, it should directly be a case. Maybe the case is a bit buggy though. What's happening on this one? This one looks correct. it takes simx, which is here a value that returns an x, then it, it compares it, it forces it. Well, it forces it later. Yeah, yeah. I guess it's a forcing here. Well, that's a thunk. But you have this thing, and you say, oh, when you've got the value of x, so that's a computation returning an x. When you have the value of x, give me the x and compare it to and pattern match on it, basically. Yeah, that sounds good. That's not what we're seeing here. Step command. I remove everything. And there, I'm not really sure, so I get the x and the y and the. And what is this? So I have the pattern matching here. The first thing that I should do is I get the x and I force it somehow. So why is it here? Why is it that? What's my definition of a lambda? That's great. That's not what I wrote though. That would be the case if that was a call by value lambda, basically, sort of. It's like the low level lambda, the one that takes a value and returns a thingy. So I said, oh, but I don't get a you don't give me a value, you give me a computation, which is this is a kind of bizarre thing. I think I messed something up, but I also can't explain why what we're seeing is happening. So I think something is a bit weird here, maybe. But I also think that even if it was weird and it would give very weird results, I should never observe variables getting out of scope. Like I could have infinite behaviors, that's fine, but not variables getting out of scopes. So there are several bugs that I need to fix, and I think that will be all, because it's high time for me to go to sleep, for one thing. And I have made zero progress in the last half hour, so I'm a tad frustrated. And yeah, okay, that doesn't trigger, but that's fine. I really don't. I should stop and come back to that with a fresher mind another day. So that's what I'm going to do. I'm going to say goodbye. And I don't think we're going to revisit it all that much, because there's not much more to say. It's pretty much efficient, and I can like play with it from time to time to show progress on slightly better improvements. That's all for me. I'm going to cut stream now. So have fun and a good night or day or whatever it is for you. And until next time, don't forget to stay curious.